Good afternoon, everybody. JC, thank you for your presentation. Appreciate you giving a lot of background into Rheocasting, so I don't have to do it. My intent today is, as a die caster, we look at Rheocasting for multiple different opportunities. You hear how great it is about one thing, about the another. We are working together with several automotive OEM customers developing structural parts. But for us personally, Spartan Light Metal Products has been a powertrain supplier to the industry. And for us, we see two major benefits to that, one of which is tool life. Now, conservatively, we're being told that we can get twice the lifetime out of a die casting tool. And when you're looking at $250,000, $300,000+ for a tool, that's a really big deal. The other benefit of that to us is you can take a part that would traditionally go in a 2,000-ton machine, and you can put it in a 1,200, 1,400-ton machine. So the opportunity there to go multi-cavity really is very, very attractive to us. So I'm going to talk through a little bit more about powertrain alloys, the work we've done to date. We've had our slurry maker from Comptech now for in development for just over a year. So very quickly, a little bit of history into the company. We are a US high-pressure die caster. We are based in and around the St. Louis area. We have 4 manufacturing plants. In total, about 45 die cast machines ranging from 1,000 tons up to 5,000 tons. Primarily, we do aluminium, but we also have about 10% magnesium production. We've been producing magnesium die castings now for well over 40 years. On a lot of our facilities, we also do significant machining and assembly work for our customers. We're primarily automotive. We have maybe 10% in agricultural. We have support offices in the Detroit area, in Tokyo, and we also have a technical partnership here in Germany and in China with KS, Huayu, Alutech, allowing us to work on our customers' global programs. Like a lot of other die casting companies, Spartan, we provide high-level, detailed, technological engineering solutions. Myself and my team, we have, not going to go through all of that, full development capabilities to support our customers from black box design all the way through. Now, more importantly, why everybody's here today to talk about Rheocasting. One of the big differentials you'll see when you're trying to set process parameters for Rheocasting is the liquidus to solidus. You can see here on this graph, a lot of the structural alloys will typically use 356, as JC mentioned, echo melt. And with those, the difference between liquidus and solidus is significant and gives you a really wide process window. But when you're looking at alloys which are much, much higher in silicon content, a lot closer to the eutectic point, we're working in a very, very narrow process window. So setup, preparation, allowing the whole thermal envelope of the system to stabilize before you start production, we've found from our trials is very, very important. We've been doing trials in terms of traditional powertrain alloys. We can't use, and I'm using US names for them, but A383, the silicon content is too high, and that is too close to the eutectic point. But we've been using A380 and A319. So you can see here's just a couple of images of the grain structures between a traditional dendritic structure in like an A383 alloy. And there, over on the right-hand side there, you can see the globular microstructure that you have there in the Rheocast alloy. And very, very different as you push it out of the shot sleeve. Here, you can see the difference. Apologies for the quality of the tray, but very different between liquid and the Rheocast slurry. which this, even though it appears to have solidified, is still movable, so you can continue to push it through the die much, much more slowly, maintaining a laminar flow with the front there. Okay. The other thing to control is your shot speed. Very traditional at the top there, and as we went through our development steps, we got slower and slower, almost down to about 3.5 inches per second. Another thing I talked earlier about the impact on the tooling. This is a brand new tool when it first went in. Then with the Rheocasting trials, you can see little tiny areas where we're starting to get a little bit of solder buildup. But when we compare that to a production tool that has run a shift's worth, you can see how much more significant buildup on the tool is. So for us, it's a lot less maintenance cost, a lot less tool work, a lot less time pulling the tool out. So real benefits there. Some of the things we had to do to our production die to get to that stage and to get an improved part from current production. We start with our current runner. We went thicker on the gates initially. Then we found we had to go to a single 8mm ring gate. In fact, our next iteration that we're running in about a month's time will turn that 8mm up to a 13mm gate. Here's some of the feedback, the X-ray and CT scan results we have. So this is a production part here today. When we first tried to use slurry and shoot it using exactly the same shot speed, only very, very minor differences, slight improvement. Then we try slowing the shot speed down to about 15%, and this looks terrible. It certainly did when we cut it apart. And as we developed that further, we found that we go a little bit slower, but significantly open up and go to a single ring gate, so we get a nice laminar flow through the tool. We've got a much cleaner part. So you can see a couple of little bits of shrink, but that's more sponge than it is anything else, and we're going to go a little bit further than that in our next trial. There's some more pictures here. That's the part on the right that we've been trialing it with. Production, you can see very, very scattered small porosity there. In the Rheo gate, nothing. Next steps for us, we're looking to go, again, I said putting bigger parts in smaller machines. Well, we're looking to take a part that currently runs in a 1,600-ton machine today. We're going to go dual cavity in the same machine. So that's a significant cost benefit to us year on year. We're going with a true Rheocast gate solution as opposed to the modified production die. So we're going to go 3-plate center shot on that one. That very quickly is the cell that we have laid out here. This is our normal production furnace. This is a 1,600-ton Bueller Prince machine here. And here is the Rheocast cell here, where we've managed to squeeze it in. So they do fit, even in fairly mature processes. That's a picture of it there within the overall cell. Very quickly, lastly, for our own development, we have designed and built an S die. This is a 9-stage interchangeable. Each set of inserts in the cover and ejector here, we can swap out. We can put any shape we want in to test the flow through this using Rheocast or high pressure. A number of our customers have come to us and say, oh, could we try this? Can we put this in the tool? So it's actually become more than just our development die. A lot of other people are using it as well. So please feel free to come down, visit us down in Hall 5, 162-F. We've got one of these parts to take a look at. Other than that, thank you very much, everybody. Appreciate your time.
Thank you very much, Chris. Thank you very much.